here. All right, any questions?
None that I haven't figured out yet.
So have other people found the compare to method in the string class?
Yeah, I wasn't sure, does it give you a number that indicates the alphabetical order, or is it like the sum of all of the values?
It should be alphabetical.
I found a description of it on tutorials points.
Oh, okay.
Including what each feedback means.
Okay. So compare to takes another string based on Unicode values, which for us are basically ASCII. 0 if they're equal. If they're different, they have different characters at an index, and it's wherever they differ, it takes the difference in those characters. So less than 0 if the string is less than the string argument. So it compares your current object to the thing you passed to the compare to method. And if your current object is smaller, if it comes before, you get a negative value. If it comes after, you get a positive value. And as usual, write some test code. You know how to pass arguments to a main method. So go ahead and compare your argument to haha. Right, and then just feed different arguments, see what string 2 gives, what compare 2 gives you back. And as with string compare, it's the sense of it that matters, positive, negative, or 0. All right. Where was my fun class? I don't know. Somewhere. All right. Let's write a very useful Java class for doing addition.
Shouldn't you start it with fun?
It's called add.
Oh.
I changed it.
Oh, okay.
I'm fast that way. All right, so here's a class called add. It's got a public static void main method. What are we going to do? We're going to take 2 arguments, we're going to add them together and print out the sum. So we can do addition. So how do we convert a string to an integer? So we talked about statics yesterday. There are some static methods inside this class called integer. And one of these methods is called Parse Int. And Parse Int takes a string, converts it to an integer, and returns that int. And it's a static method. So we can access it with the class name integer.parseInt and pass it a string. So we can do this. Take arg0, that's the first argument on our command line when we say java space add. And let's turn it into an integer I. And then let's do the same thing with the second argument. Put that in an integer called j. Let's add them together. And there's a confusing line because I didn't put any spaces in. But let's print out I, a plus sign, a j, an equal sign, and then print out the sum of I and j. So we'll compile that. And we'll do Java add, and we'll feed it 4 and 5. And it tells us 4 plus 5 equals 9. So there's a handy dandy calculator program. And negative 20 plus 11 is negative 9. So it works on negatives. And this is great until we try to add 5 to haha. And now we get really ugly output. And it says exception in thread main, Java language number format exception for input string haha. Bless you. And it's giving us what's called a stack trace. It's telling us where this error occurred. And the stack trace, it's a stack, reads from bottom to top. It's saying we were at add.main, which was line 5 in this file, add.java. And if we look at line 5 in add.java, that's where we called integer.parseInt on args bracket 1. And so at that point we called integer.parseInt, and at line 615 in this file integer.java, which we didn't write, but that's the Java file that corresponds to the integer class, it called parseInt, which got down to line 580 in integer.java, and it got upset at that point, and it executed something inside this Java language number format exception for input string down at line 65 in number format exception.java. So we're seeing who called who, and who did they call, and who did they call, and so on. And our program add called parseInt, which also called parseInt, which called something inside number format exception.java, and then at line 65 it printed out this error message. And there we got an error from line 4 of add.java because the first argument, args bracket 0, was the one that generated the problem. And once it generated that problem, it never went on to add.java line 5. My program exited at that point. So there's line 4. That's where it encountered the first problem because args 0 was haha, and my program just gave up. And it's pretty hard to write code that will look at args bracket 0 and know if this is going to generate an exception. Because we basically need to say, is this a valid integer? Well, it could start with a minus sign, it could start with a plus sign, it could start with no sign. It should begin with an integer, it should be a succession of integers. Has to have at least one integer. If we were trying to parse a double, it gets way more complex. Because it could have a decimal point somewhere, it could have an e somewhere for an exponent, and the exponent could be followed by a minus sign. And it's not easy to do that, but we don't have to. So there's a mechanism in Java for dealing with these exceptions. And there's a way we can say, when an exception occurs, I want you to do something special. So what is an exception, first of all? Something happened, it said number format exception, and my program printed out this stuff and then exited. So how many people have had 270?
I forget 270.
But you took it.
I believe so.
Okay. So in 270 we talk about interrupts. Right? So what's an interrupt? It's something that happens outside the system. This pin of this processor suddenly got 5 volts on it, and suddenly your code's doing something different. Your code was minding its own business. I'm going to do this, I'm going to do this, I'm going to do this, I'm going to do, oh, wait a minute, that pin just went to 5 volts, hold that thought, jump over here, start doing some other stuff. And when you're done with that, come back to where you were and continue as if nothing had happened. That's how an interrupt works. An exception is kind of like a software interrupt. Same sort of behavior, but instead of responding to, say, a voltage level on a pin, it responds to some kind of software event. For example, you try to convert a string to an integer and you can't. And instead of going on to the next instruction in my Java code, it says, hold on, let's go over here and do something. And what it does is it prints out all of this information and then it causes the program to exit.
But you can modify that.
But you can modify that, just like you can with interrupts. So in interrupts, we can set up an interrupt handler. In 270, we put code at location 8 or 18. Sorry for the flashbacks. And now when an interrupt occurs, we're going to come to this section of code, and we can put code there to do something. Let's turn on an LED, right, or whatever. Well, we can do the same thing in software. And most languages, most operating systems have ways to deal with these exceptions, these software interrupts. So in Java, it's a pretty slick system. We can create what's called a try-catch block. So we write the keyword try, followed by whatever set of code we want to execute, which might cause an exception. And then we write the word catch, and we're going to put something inside here, and we write curly brackets, and we put more code down here. Okay, so we're coming along, we're executing code, everything's fine. We get to the keyword try. It starts executing these instructions inside this try block. If all of these finish, it skips the catch block and it continues down here. So the catch block's kind of invisible. But if it's executing things in the try block, and let's say right here, something exceptional happens, it jumps down to the catch block and it starts executing these instructions. And then when it's done, it comes down to the rest of this outside the try-catch block. So we're basically saying if anything odd happens in here, jump down to this block of code and start executing it. So that's the catch block. But it turns out there's different kinds of things that can go wrong. So we need to specify what type of exception should this code be executed for. And that's where we can specify something like number format exception. And so this is almost like a method. It's not, but it's almost like a method in that it has a signature. And the signature is basically, let's specify a type of exception. As a type of variable argument. So if we say number format exception var, it means that if a number format exception occurs here, take some information about that exception, set var equal to that, and then execute this code. So it's kind of like calling a function, except we don't return from here. We don't go back up to where the exception occurred. It's more like a jump, but we're jumping into this set of code and we're setting a variable equal to that exception. We'll write some code shortly, which will be clearer than describing this in words. So let's use this. So now this one line of code that might throw an exception, parse int, is inside a try block. And if it generates that number format exception, I will jump down to my catch block. I'll print out the message error. I'll print out what the value of arg0 is, and I'll say it's not a valid integer. And I'm going to do the same thing here for j. And if the conversion works fine in that first case and it works fine in that second case, we ignore the catch blocks. Now we come down here, we add I and j, store that in sum, and we print out what their sum is. So you with me on the mechanics of try-catch so far. All right, this will not compile. It's going to complain about something. It's going to say that it can't find I and J down at line 18. So right there, can't find I and J. Well, why not? I defined I and I defined J. Why can't it find I and J?
I remember when I had the same problem before. It
Yeah.
doesn't know if you're going to go through the loop or not.
Right. So there's this notion of scoping of variables, right? If I define a variable right here, after this curly bracket, that variable is accessible anywhere inside this method. If I define a variable right here as part of the class, it's accessible anywhere in the class. Here I've defined my integer I inside this try block. It's only available on this one line. And once I come outside of this block, I is gone. It's local to this block right here. So there's always a scoping to variables. What's the area of code in which this variable exists? And it's generally scoped by the smallest curly brackets. And this is like when you say for integer I equals 0, blah, blah, blah. Once you come out of here, that variable I no longer has any meaning. Right? It was local to that for loop. So this I is local to this try block, and the J is also local. Easy to fix. Just set those up outside and then refer to them. Now if I still said integer J here, this is a different J from the one up here. Right? It's a more local, more tightly scoped. But if I just say J, what J is it referring to? It's got to be this one up here. And down here, when I say sum equals I plus J, it's going to have to use that I and that J. So this should work well. So 1 plus 2 is 3. 1 plus haha says haha is not a valid integer. Haha plus 2, same thing. And haha hee hee, same thing. But now we're not getting all of those extra output messages. All of this stuff up here. Right, we're handling those exceptions ourselves.
Does it try slow down your program? Is it checking it constantly?
It's basically, because these things are exceptions, right? When something goes wrong, normally we jump over here and we print out all this error message stuff. It's really just changing the response when an exception occurs. So it's not checking constantly, yeah. It's a really cool system. And it's part of every language, every operating system, basically, at some level. And there's a way to deal with these. This is what happens when you access a memory location that's not available. All right, you get an exception, usually from the memory management system, saying, hey, problem, memory. All right, so number format exception. Well, this is a class. And we can look at the Java doc on number format exception, which is a type of illegal arguments exception, which is a type of runtime exception, which is a type of exception. And a number format exception is thrown to indicate the application. The attempt to convert a string to one of the numeric types with a string does not have the appropriate format. So throwing is terminology for basically signaling an exception. When you throw an exception, you basically raise a flag and say, hey, something exceptional happened. But the terminology in Unix and C is throwing an exception, and Java. But a number format exception is a type of class, which means we can construct objects of type number format exception. And so in our code, when we come down to our catch block, remember this is like a signature. This is saying, I want you to take this thing variable, which is an object of type number format exception, and give it a value that tells me what happened. So in some sense, the error occurs, it's kind of like a call is made to this set of code, and the value of this variable, in this case var, is set to something that tells you about the exception. It's kind of like an argument, except it's not really a call. It's more like a jump. So what is a number format exception? Well, as I said, it's an illegal argument exception, a runtime exception. It's a type of exception. So what does an exception mean? Well, exceptions have methods. They have a toString method. They also have a print stack trace method, which says print backtrace of the specific whatever caused the exception. So let's just play with this. Let's put some code in here. Let's print out the value
Does
of...
var need a plus in front of it?
It does. Thank you. Okay, so the value of var is, and I'll print out the actual value of var inside angle brackets. Of course, we're calling the toString method of var, which is a number format exception. So hopefully the toString does something reasonable. So it tells me ha is not a valid integer. That's our message, and then it says the value of var is, it's a string, Java language number format exception for input string ha. And in this case, it's always going to look like that. So I can parse this. I can look for the double quotes and see exactly what string it complained about. I can look at the beginning up to the colon, and I can know in a standard format what the type of the exception was. Print stack trace. So I'm going to say here's the result of print stack trace, and I'm going to call the print stack trace method. Right? It's a method inside number format exception, so it's a method of var. So I'm going to say var.print stack trace paren. And then we'll print a message at the end so we know where this is done.
Is it long?
It's what?
Is it long?
Maybe. Not too long for us. So we have access to a bunch of information here. All right, we use the try catch mechanism to say come down and execute this code if an error occurs. And inside that code we have this argument, this variable that we can call whatever we want. And it's an object, so it has the ability to tell us a readable description of the error, to show us a stack trace, who called who, and so on, and other things as well.
That kind of looks like what happened before we did the catch.
It's exactly what happened before we got the catch, because that's the default behavior of an exception if you don't have a try catch block, is to go ahead and print out the toString of the exception and then print out the stack trace. All right, what if I run my add program but I forget to give it any arguments? Well, I got a different kind of exception. Array index out of bounds exception.
No arguments inputted.
No arguments inputted. So let me get rid of all of this extra stuff. So we normally, oh, that's not what I wanted.
Print stack trace.
Alright. This code's already over on the server, so. Alright, so we get a nice short amount of output here if we have an invalid integer. But if we forget to specify arguments, we get a longer output. We get this random error message and we get a one-line stack trace. So this is an array out of bounds exception. So I'm going to add another catch block, which is going to say if we have an error of type array index out of bounds exception, let's just print out this error message and say goodbye.
You can do multiple catches.
You can do multiple catches. So wrong format, it says not a valid integer. Forget to specify, it says array went out of bounds. So we can say try code catch exception 1 code catch exception type 2 code, and so on. And we can also say finally and put in some final statements that we want executed. Now a finally block's not going to do it. Yes?
Is there a reason you can't try both first and second arguments in one try block?
I think you can put them in one try block, but I'm going to get rid of them shortly anyway. So let me get rid of some of these comments. So let me get rid of these returns. And instead of this, let's just say, let's just default I and j to 0. And let's put a finally block on here. I never used finally blocks, so there's a chance this isn't going to work. Looks really wrong to me, but we'll find out. So if I add 2 and 3, it says we're in the finally block now, and it tells me 2 plus 3 equals 5. If I add ha and ha, It gave me an error for the first one, ha's not a valid integer, said goodbye, went into the finally block. And then it said ha's, so let me do ha and ho. And then it said ho's not a valid integer, goodbye, we're in the finally block now.
And nothing happened after that.
And nothing happened after that.
Because I could have stopped the program.
Because I still had a return. So it said 0 plus 0 equals 0. And if I forget to put in arguments, it tells me the array went out of bounds, that if you get an argument, we're in the finally block. Array went out of bounds, that if you get an argument, we're in the finally block. Final block. And then you print it out 0 plus 0. So what's the general setup here? You try to do the things in the try block. If you succeed, you come down to the finally block and then you continue. If you get an exception, you go to the matching catch block, execute that code, and then go to the finally block. But you always execute what's in the finally block. Now let's put our returns back in here, so that after we say goodbye, we do our return. So it said ha's not a valid integer, goodbye. It still said we're in the finally block now, and then it did the return. So it said not a valid integer, it said goodbye, but before it did the return, it jumped down here to the finally block, did this, and then went ahead and did the return. So that seems a little weird to me and other people, because it's like it sees the return and it says, okay, but I'm going to do the finally block first, and then I'll go ahead and do the return. But that's what it does. Like I say, I've never actually used finally blocks myself, but it's a thing, and it's useful sometimes. But you do not really want to write code like this. The first thing is fine to check to see if we've got a number format exception. That makes good sense, because it's really hard to tell if args bracket 0 is a valid integer or not. But this is really kind of heavy-handed, because there's an easier way to tell if we're going to go out of bounds. Just check the length of your array. It's pretty easy to start using exception try-catch blocks as a crutch, to write really sloppy code and just put everything inside a try-catch block and say, if something goes wrong, we'll just come down here and deal with it, right? And that's kind of what we're doing here. We want two arguments, and if they don't happen to have an arg0, well, we'll just come down here and handle it. Try-catch blocks are kind of inherently confusing, and if you're trying to read your code, you got to know that you're going to jump down there. It's almost like having random go-tos. It can make your code fairly convoluted. So if you really need to use one, go ahead and use one. But there's a better way to deal with this case. Which might be something like this. Same thing we do in C. Let's see if you actually have two arguments. So args is an array. We get its length by looking at the field called length. It's not length paren like for a string. It's not a method. It's just a field in the array. So if args length is not 2, we'll say error. You need exactly 2 arguments. We'll say goodbye and we'll just leave. Otherwise, we know we're not going to get an exception when we use args bracket 0 or args bracket 1. So now we can just catch the number format exception. And I'm going to get rid of the finally blocks because we don't need them. So we don't need this array out of bounds. And so that's a little simpler code. So if you don't have the right number of arguments, it'll tell you that you need exactly 2. And if you have arguments but they're not integers, it'll tell you they're not a valid integer. And if you have integers, then it'll go ahead and do the addition. All right, one other detail. There's a hierarchy of exceptions. So a Java language number format exception is actually an illegal argument exception, is actually a runtime exception, is actually an exception. So I could catch on a runtime exception. And since a number format exception is a runtime exception, it should still come into my try catch block, even though I said catch runtime exceptions. This means the easiest way to write a catch block is just to say catch an exception. And now any exception that occurs is going to go into that block. So if I just say catch on an exception, any exception will go into there. Which means if I still want to be sloppy and not check my number of arguments, that's going to throw, oh. Didn't expect that. Oh, line 17. Oh. Alright, so if you don't have the right number of arguments, it'll go ahead and it'll just jump you into the same catch block. That's sloppy, but it's also a little faster to work with sometimes. So dealer's choice. Again, you usually want to use these in kind of the smallest context possible. I could put my entire method inside a try catch block and have my catch block just be something went wrong and return. And now I won't get an unhandled exception that exits my program. But you really don't want to do that. You really want to just put this right around where you think you might have a problem. Usually one line of code or a few lines of code. This is something that IDEs will do for you. If you write a statement that could throw an exception, it'll usually say something like, you know, this should be in a try catch block. Would you like me to make one for you? And you can click on something and it'll write all of the try catch stuff. And you just fill in the details. Because it's one of those things we do a fair amount. All right, got the idea of that? Okay. Don't rely on it too heavily.
Could you make this a really general use try catch class and just include that in the files that you wrote?
You could.
Obviously, you don't want to rely on that.
But yeah. So like I said, you could put a try in the very beginning of your method, and all the way to the end. If anything goes wrong, it'll jump down to your catch. And people do that, but it's not always good.
Sure.
Cool. All right, got the idea? All right, we have 5 minutes and 22 seconds. So, how many people downloaded IntelliJ? How many people got it running to where it would at least like start? Okay, cool. So for me, I'm on a Linux system, and IntelliJ seemed to come as a shell script that I had to run, and it produces all kinds of output. So I made an alias, IJ, for IntelliJ. So I just type in IJ, and that should run this in the background. So there's IntelliJ coming up. It can take some time. So it's chewing 37% of my CPU, 48%. This morning I was doing like 103%, which is impressive. There's 151%. Cool. I got 4 cores, so I can go up to 400. So it can take a while to start. Eventually you get down here and there's options here. So let's create a new project. And we're going to go through this really fast. We're going to go through it a lot more carefully tomorrow. General rule of thumb, take defaults. All right, you don't know what something does, don't change it. So we're just going to go with a Java project. I'm going to say next. I'm not going to check anything here. I'm just going to say next. First time you do this, set up this project location to somewhere reasonable for your system. That means somewhere that you back up, somewhere that you put your stuff usually. And let's give our project a title, so I'll call it 223B. And it's going to put everything in this subdirectory under my projects folder, 223B. And wait. And so here's the Ide Setup. Gives you the tip of the day. You can disable that, but I like to pretend I'm going to read them someday. So here's our development window. So just like MPLab and MATLAB and a lot of these other things, over here is sort of our project window. This shows us all the pieces of our project. This is where other things are going to happen, including editing our code. I'm going to double click on 223B, come down here to source. I'm going to right click, and I'm going to say new, and I'm going to say let's make a new Java class. And I'll just call this main class 171, so it sounds fancy. So there it's created the beginning of main class 171, said public class main class 171. I have VI hooked into this so I can do VI commands. So let's do public static void main, string bracket args. And it does lots of stuff for you, right? As soon as I hit the left brace, it typed a right brace to match it. As soon as I hit enter, it's going to move that brace down. And now I'm going to come up here and I'm going to say system.out, and it's giving me suggestions while I'm typing. .print line. So I'm just going to print out a message. So there's my test program. So to build it, you can go to run and build. I'm just going to hit the little hammer over here, because hammers are like synonymous with building, I guess. And down here it says it's building, it's parsing. Compilation completed successfully, 3 seconds, 765 milliseconds. And now I'm going to run it. Normally I'll have a run arrow here. The first time you do this, you got to go to run, and you got to say run, and then it's going to say, what do you want to run? I want to run from main class 171. So I'll click that. It'll work on it. It runs. There's my output. We just did our hello world. All right, I'm going to change it. I'm also going to print out the word bye. I want to run this. I'm just going to hit the green arrow. That's going to do the build. It's going to check the syntax. It's going to make the class. It's going to execute it. There's the output. Okay, IDEs are about rapid development. They're about, I don't want to spend time typing JAVAC space blah 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 .java return, right? It's about spending your time thinking about the code, writing the code, debugging your program, running it, seeing what the output is, not spending time with building it and editing it and that kind of stuff. So IDEs are usually trying to streamline those parts of it as much as possible. So we're going to start playing with this tomorrow. Okay, we're going to go through the details of how you make a project. We're going to play with some different types of code. We'll see some of the things that this does for us, and we're going to start making some GUIs. So we'll make some things with buttons and text areas and stuff like that. And this will be what we use for PA3. All right. Thursday's still going to be an open lab. I'm going to do that again this week. So I'll remind people of that tomorrow. All right. Did the sign-in sheet make it to everybody?
Yeah,
All right. Cool. Question?
This Thursday?
Yes. Okay.
Was there any reason why to delete or other IDs such as
Okay, so you're good to go. I'll see you tomorrow. So we used to use Eclipse. Eclipse has gotten quirky to use, particularly with trying to do GUIs. It got to the point last year that it was almost unusable. You really had to roll back to an older version of Java. We're using something called Window Builder, and according to the online discussions, there's no Window Builder developers around, or there weren't last year. And they got to a point where Java got to version 10. They were taking the last digit of the Java version string, comparing it to what they wanted, and they thought that we were on Java version 0. And said, you need a newer version of Java. Yeah, it's just a bug. But it was a cheap way to convert to an integer, just take the last digit. And so people had to roll back to an earlier version of Java, and it just got to be...
I think I have like 8 or 7 on mine. So.
Yeah. But I went back and I looked at the